Evaluating GenAI applications can become really tricky, and this is where MLflow helps to simplify the process. MLflow's evaluation library has different types of evaluation schemes. Either you can use the human feedbacks and annotate your traces, or if in case you don't have the ground truth information, you can use LLM-as-a-judge to analyze and assess the performance of your prediction. Or even you can come up with your own custom scorer to create your business metric and understand the performance of the models. In this video, we are going to see how we can create our own custom scorer to analyze the performance of the invoice extraction. Let's get started. Before we go ahead and talk about the custom scorer, let's have a quick look into the things that we have done so far. So we started with the setting up the environment, like setting up calculation variables where they were those to use GPT-5 Nano and with the low reasoning level, and we set up the auto lock. The next step was to set up the prompt. Here we have registered a prompt for invoice extraction. The third step was to perform the data preparation. To do that, we loaded the V2 data set and we created the data set in this particular format, right? And then once the data set was ready, with 64 URLs and the schema information, the next step was to write a custom predict function, which is going to send in this input to the OpenAI endpoint, extract the response text, and return it back. Okay, let's go ahead and take a quick look into how we can create a custom scorer. For creating a custom scorer, you have to write a method and tag it with a decorator add scorer. And this method can take different types of arguments. In our case, we have inputs, which is the invoice in basic shipper format, and outputs is the prediction from the OpenAI endpoint. The expectations, the ground truth, and the trace contains the trace information. We are going to talk about this code block in detail in the next video, but all we are doing in this particular exact match method, this could be derive a metric. In order to derive the metric, we are going to compare the ground truth and the prediction key-wise for every single invoice. We are going to compare the values of the ground truth against the prediction and see in the values matches. In this custom scorer, we are going to evaluate the accuracy of the extraction. And for that, we have this method calculate individual invoice accuracies. This method takes in the ground truth and the output. For every single invoice, we have this ground truth and output. And the first step is to flatten this prediction and ground truth. The reason for doing this is because if you look at the input, we have different set of menus, and the menus are represented as a list. And in order to compare the ground truth against the prediction, we can flatten these keys in a single JSON hierarchy and perform one-to-one comparison. And the next step is a very simple post-processing step where we are replacing comma by full stop for the price tags in order to have a unified currency. For every single key in the ground truth, we are validating if the value in the ground truth is matching with value in the prediction. If it is the case, then we are setting this match to true, or else we are setting it to false. And we derive the accuracy metric by just identifying how many ground truth keys that we were able to match. And then we return this accuracy metric along with a detailed data frame of what was the key, what was the ground truth value, what was the prediction, basically for the later analysis. As soon as we receive the accuracy for one particular invoice, we can create this feedback where we return this information to MLflow. If objective of this particular method is just to calculate the accuracy every single invoice, we don't need these many lines of code. We can just have only 4 lines of code like this, where we gather the output, we gather the prediction, and then calculate the overall accuracy for that particular invoice, and then just return the metric to MLflow. But we can do more. The reason for doing more is because at a longer run, we want to understand the model prediction and see what are the keys where the prediction was a mess. And then we have to update our prompt in order to account such cases. To do that, we are going to make use of the parent-child concept in MLflow, where in every single run, we can nest a couple of child runs. In our case, the parent run is going to be the run with the model, for instance, GPT-5 Nano with low reasoning level, and every single child run is an invoice. So here we can see for every, as we know, this exact method will be invoked for every single invoice. And for every single invoice, I'm going to create a child run. And inside the child run, I'm logging, all the information about that particular invoice. I'm going to log the image as such, the prediction, the ground truth, the computed accuracy, and even key by key comparison, which we did in this particular method. Let's quickly run this and see how it appears in MLflow UI. Let's run this method. And all we have to do is to bind together the data, the scorer, and the prediction function. Let's run this and wait for prediction to be successful. Let's just wait for it. It has started. Now you should be able to see the progress bar. Okay, here we have the progress bar. We have running prediction with 10 items. Okay, the predictions have started. You can see. Let's wait for it to complete. We have all 10 invoices extracted. Let's have a quick look into the MLflow UI to see what are the information that has been logged. Okay, we have opened the MLflow. So this is my recent experiment. As I said, this is the parent run, which is GPT-5 Nano, and we are evaluating at low reasoning level. And here you can see all the 10 different invoices which we extracted. Let's open this one. As we mentioned, we are calculating the invoice level accuracy. Here, the accuracy was like 83%, right? But just by looking at this metric, we cannot understand what was good and what was bad. To do that, we can go to the artifacts tab. In this tab, we can see, so this was the input image, and this was the ground truth, and this was the prediction from the model. And here we have the keywise prediction. What was the ground truth value? What was the prediction value? Whether it matched or not, right? Based on this, we are calculating the accuracy metric. The one another cool thing about MLflow is that it automatically aggregates these metrics. So we have individual metrics for all these invoices, but we can also go to the parent run, and here you can see it has the aggregated metric for all 10 invoices as such. So this is the mean metric, one number by which you can see what was the average accuracy.